Good morning, student. How are you? I hope all of you well. Student, in previous lecture we start our next second lesson of our subject Science and Technology paper first, and that is periodic classification of element. So just we can recall all those points we studied in previous video. Student, we studied what is elements, classification of elements, and some scientists who firstly classified the known elements. Okay, so first, Dobereiner's trade. I told you that Dobereiner was first tried to arrange the elements. How he arranged the elements? He arranged the elements, but on the basis of that he made a group of three elements, and first and third element, the mean of first and third element is approximately near about the atomic mass of the middle one. Next scientist who tried to classify the element that we studied was Newland's law of Actu. What he did in his classification? In his classification, he arranged the known elements according to increasing order of their atomic masses. And while he arranged Newland, he found that every 8 element had properties similar to those of the first. Just example, sodium. He gave the example of sodium is the 8 element from lithium, and it shows the similar properties. Okay, he arranged all these elements in resembling with the music. Okay, in the previous lecture I also show you whatever the table of Newland. Student, I also explain about some limitations of Newland's octave. Newland could not arrange 56 elements. He arranged the elements up to calcium. Okay, his arrangement started with a lightest element, that is hydrogen, and ended up with the thorium. Newland placed the metals cobalt and nickel under the note Do. Do was one of the musical note, along with the halogen, while ferrous having similarity with cobalt and nickel away from them. Okay. The properties of new elements discovered later did not fit in Newland's law of octave. But whatever he did, that was he firstly give the concept of period. That is, period means after certain interval, some properties or something are repeated. So firstly, he tried to give this concept. And next classification that was given by Mendeleev. Mendeleev's classification is very important one, because whatever he did in the field of classification of element, that was the first systematic classification, and whatever table he arranged, that having lot of significance. The today's modern periodic table is based on his classification. Student, what he did? Mendeleev used the fundamental property of element, that is atomic masses. He arranged the elements as increasing order of their atomic masses. Okay. Student, while he studying the chemical properties, he also studies the chemical properties of elements with their oxides and hydrides, and he studied the physical property with their boiling points, melting points, and densities of the elements. Student, while he arranging all the elements by using their physical and chemical properties on the basis of atomic masses, he found that the properties of elements are periodic function of their atomic masses. Okay, what the properties of elements are the periodic function of their atomic masses. He leaves some gaps in periodic table. You Observe this. This is the Mendeleev's periodic table. He leaves some gap in the periodic table for it to be discovered elements. The provision of to accommodate it to be discovered noble gases. It means that whatever the benefits or merits of Mendeleev's periodic table, so you observe this table, you will find some vacant places here. Okay, so these places are for unknown elements, that elements which is later on discovered. Another thing is that we can arrange the noble gases without disturbing his table. Student, you know the noble gases or inert gases, such a gases which are having completely filled orbits, okay, or they are mostly chemically inactive. So these uh, noble gases are arranged in his table without disturb his table, that is placed in zero group element. This is one of the merit of Mendeleev's periodic table. Another thing is that those elements having same properties, they place these elements in similar or in same place. Okay, but along with this merit, some demerits found in Mendeleev's periodic table. Let's see whatever the demerits of Mendeleev's periodic table. The demerits was the element cobalt and nickel. Look at here, the element cobalt and nickel have a same atomic masses. As a result, they there is confusing regarding their sequence in Mendeleev's periodic table. Another problem was regarding with isotopes. Student, you know that isotopes are such a atom of the elements who having same atomic number but different atomic masses. So there is confusion or there is no exact position of isotopes. It was challenged to post the position in Mendeleev's periodic table regarding with isotopes. Next, he was quite confused about the position of hydrogen. Why? Because hydrogen shows similarities with halogen group, just like H2, Fe2, Cl2. These are the diatomic molecular formulas, or they are diatomic in natures, and it is difficult to decide its correct position, hydrogen's correct position, whether they are placed, whether it placed with alkali group or maybe with the halogen groups. Okay, student, he also placed some elements who having less atomic, more atomic masses than the less atomic mass number, and whatever law he predicted, that was the increasing order of atomic masses, this was not followed in some cases. These all are the demerits of Mendeleev's periodic table. Now move towards the next concept, that is modern periodic table. Modern periodic table is very important one. The scientific word did not know about the atomic number at the time or the actual structure of atom when the periodic tables are designed by Mendeleev. Later on, you know that the Rutherford suggested the atomic model. Okay, so this atomic model was later on it is invented after the invention of Mendeleev's periodic table. So Henry Moseley was the scientist in 1913, and he made the first periodic table or first arrangement of classification of all the known elements according to the atomic number. What he stated? He stated that the atomic number is the basic fundamental properties, okay, not the atomic masses. So what he said, he done the experiment by using X-ray tube, and then he stated that atomic number of an element is the positive charge on the nucleus of that atom or the number of proton in the nucleus of an atom of that element, and this resulted that atomic number is more fundamental property of a element than its atomic masses. Therefore, according to the statement of modern periodic law, what it stated what the modern periodic law was stated, it was stated that the properties of elements are the periodic function of their atomic numbers, not the atomic masses. Listen very carefully. According to the Mendel's periodic table, the properties of elements are periodic function of their atomic masses, but according to the modern periodic law, the properties of elements are the periodic function of their atomic numbers, not the atomic masses. Okay, I hope all of you understand this. The classification of elements resulting from an arrangement of element is an increasing order of their atomic numbers is the modern periodic table. The properties of element can be predicted more accurately with the help of modern periodic table on the basis of atomic numbers. Okay? The modern periodic table is completely based on increasing order of their atomic numbers. Understand? So most of the drawback, whatever drawback of Mendel's periodic table appear, it will removed while we are arrange the elements according to atomic number. इसका मतलब ये है कि Mendel's periodic table में हमने जो भी demerits देखे, हमने कौन से demerits देखे Mendel's periodic table में. He was quite confused about the position of hydrogen. There is this table cannot exactly stated about the position of isotopes, and also he placed some elements whose higher atomic masses earlier than the low atomic masses element also. So these all the problems or demerits are removed when we observe the modern periodic table, which was arranged according to atomic numbers. Okay, we have seen in previous standard that electronic configuration, you know the electronic configuration of an elements. Okay, it show the cells are there, K, L, M, N, and each cells having capacity to hold the electrons, that is 2, 8, 18 and 32. So the modern periodic table, it shows the relation between atomic numbers of elements, and this modern periodic table is clearly seen, this electronic configuration is clearly seen in the modern periodic table. Okay, so who designed this modern periodic table? Henry Moseley. Okay, now what is the structure of this modern periodic table? Student, in the modern periodic table contains 7 horizontal rows called periods, that is 1 to 7, and there is 18 vertical columns. Okay, how many? 18 vertical columns, that is called groups. So periods and group. Okay, horizontal rows are periods and the vertical columns are groups. And how many groups are there? 18 groups are there. The arrangement of periods and groups are result into formation of box. So atomic numbers are serially indicated in upper part of these boxes. Look at here. Look this modern periodic table. Here the position of hydrogen shows the exact number, upper side number, that is atomic number. Okay, and each box correspond to the one element. So it means each box shows the place of one element. Okay, this is the modern periodic table. स्ट्रक्चर ऑफ मॉडर्न पीरियोडिक टेबल कैसा है? मॉडर्न पीरियोडिक टेबल का स्ट्रक्चर ये देखिए, यहाँ पर ये जो हॉरिजेंटल रोज है इनको हम पीरियड्स कहते हैं. ओके, और ये जो वर्टिकल, नाउ लुक एट द स्ट्रक्चर ऑफ मॉडर्न पीरियोडिक टेबल. सो ये जो हॉरिजेंटल रोज है दैट इज कॉल्ड periods and the vertical columns that is called groups. So how many periods are there? 7 periods are there. And how many groups are there? 18 groups are there. Okay, okay, apart from this modern periodic table, you observe in this picture that downwards 2 periods are there. Okay, your block is written here, that is lanthanide and actinide series. This lanthanide and actinide series are the what is the position of this series? It is the below the modern periodic table. These two series, that is lanthanide and actinide series, are placed separately at the bottom of periodic table. Okay, there are how many 118 box in modern periodic table. Actually, some elements, near about 24 elements, are later on it is invented in laboratories. So they are also placed, and no any vacant box is there in modern periodic table. It means all the 118 elements are known nowadays. Now student, this element in modern periodic table are divided into four blocks. How many blocks? Four blocks. That is S block, P block, D block and F block. Okay. So the group 1 and 2 together with hydrogen form S block element. The group 13 to 18 from the P block element, and group 3 to 12 together form D block element. And the two series which are at the bottom of the periodic table, these two series, that is lanthanide and actinide series, are form F block element. Okay. The D block element are called transition element, and one zigzag line is there. You will see in this figure there is dark line. So this zigzag line, it shows the metalloids position. The all border elements of these zigzag lines are the metalloids. Okay, these periods are clearly shows the separation of metals and non-metals. Metals and non-metals. Those elements are left side of this zigzag line. All these are the metals. Once again I repeat, those elements are on the left side of this zigzag line are metals, and right side that all elements are non-metals. Understand? So these all characteristics of the group and periods in the modern periodic table are because of the electronic configuration of the element, and it is electronic configuration of an element which decide the group and period in which it is to be placed. The neighboring elements with a period differ slightly in their properties, while distance elements are differ widely in their properties. Elements in same group show similarities and graduation in their properties. Student, why it happens? Because what Moseley stated that the atomic number is the fundamental properties. ओके, ही यूज द एटॉमिक नंबर इज द फंडामेंटल प्रॉपर्टीज. इसका मतलब ये है कि एलिमेंट की जो भी प्रॉपर्टीज है ये उसके एटॉमिक नंबर की वजह से है, ना कि एटॉमिक मास नंबर की वजह से. तो आप अगर इस पूरे टेबल को अच्छे से फॉलो करते हैं तो यू विल ऑब्जर्व दैट द नेबरिंग एलिमेंट इज इंक्रीजिंग बाय 1 digit of their atomic numbers. Okay, so those are placed in one group. They all are the similar chemical properties. Okay, and you will, if you carefully studied this modern periodic table, student, if we observe this modern periodic table, we will find that the number of valence electron in all these elements form a group first, that is family of alkali metals, is the same similarity. If you look that is the same similarity if you look at the electron from any other group, you will find the number of their valence electrons to be the same. For example, element beryllium, magnesium and calcium, okay, they all belongs to group second, that is the family of alkaline earth metals, and there are two elements in their outermost shell. So similarly, there are 7 electrons in the outermost shell of the elements such as fluorine, chlorine from group 17, that is also called halogen group, and that is family of halogen. While going from top to bottom within any group, the electronic cell get added at the time. While when we are from going from top to bottom within any group, what happened? The electronic cell get added at the time. From this we can say that the electronic configuration of outermost cell is the characteristic of a particular group. However, we go down a group, the number of cells goes on increasing. Student, what it means? What it means, student? It means that when we study the periodic table, modern periodic table, we will observe that the elements are belongs from same group. Those elements are belongs from same group. They having same properties, chemical properties. Why? इसका मतलब क्या है कि हम किसी भी ग्रुप का अगर अच्छे से ऑब्जर्वेशन करते हैं तो एक बात हमारे ध्यान में आती है कि ग्रुप में हम जब ऊपर से नीचे आते हैं, किसी भी ग्रुप में हम जब ऊपर से नीचे आते हैं तो आप और अगर आपका उनका इलेक्ट्रॉनिक कॉन्फ़िगरेशन देखेंगे तो आपको एक बात समझ में आएगी कि उनके आउटर मोस्ट सेल में सेम नंबर ऑफ इलेक्ट्रॉन्स होते हैं और उनकी वैलेंसी भी सेम होती है। अंडरस्टैंड? यहाँ पर जैसे एक एग्जांपल दिया है बेरिलियम मैग्नीशियम का। ओके, ये जिस ग्रुप में है आप देखिए सेकंड ग्रुप में है तो उनकी वैलेंसी भी क्या है, 2 है। ओके, अनदर एग्जांपल गिवन रिगार्डिंग विथ हेलोजन ग्रुप दैट इज क्लोरीन फ्लोरीन। अब आप देखोगे तो उनकी भी आउटर मोस्ट ऑर्बिट में कितने हैं, 7 इलेक्ट्रॉन्स हैं। तो इसका मतलब ये है कि एक जो भी एलिमेंट, जितने भी एलिमेंट्स एक ग्रुप में होते हैं उन सब की प्रॉपर्टीज कैसी होती है, सेम होती है। और ये क्यों होता है? क्योंकि उनके जो इलेक्ट्रॉन्स होते हैं लास्ट के और सेल में वो सेम होते हैं। ओके, दैट्स व्हाई दे स्टेटेड दैट द इलेक्ट्रॉनिक कॉन्फ़िगरेशन, okay, whatever the outermost cell of is the characteristics of a particular group, and when we are goes down a group the number of cells goes on increasing. The number of cells goes on increasing. cells तो बढ़ते जाएंगे, जैसे ग्रुप, जैसे हम ग्रुप में टॉप टू बॉटम जाएंगे तो 1 होगी, के होगी, फिर यल होगी, यम होगी, लेकिन उनके इलेक्ट्रॉन की जो नंबर्स होगी, जो फिगर होगी वो कैसी होगी, सेम होगी। या फिर वैलेंस इलेक्ट्रॉन की जो नंबर्स होंगे वो कैसे होंगे, सेम होंगे किसी भी पर्टिकुलर एक ग्रुप में। अंडरस्टैंड? नाउ दिस इज रिगार्डिंग विथ ग्रुप। व्हाट हैपन विथ द पीरियड्स? व्हेन वी आर गोइंग लेफ्ट टू राइट इन अ पीरियड, that time you will observe that the number of electrons, when we are going in periods, okay, left to right, the number of electrons are increasing. Okay, the number of electrons are increasing. So we find that the number of valence electron in a different of these elements, though however the number of cells is the same. You will also find that while going from left to right within the period, the atomic number increased by 1 at the time, and the number of valence electron also increased by 1 at that time. बच्चों, इसका मतलब ये है कि जैसे हम पीरियड्स में ओके लेफ्ट टू राइट आगे आगे जाएंगे तो हमको ये ऑब्जर्वेशन मिलता है कि एक एक डिजिट से उनका एटॉमिक नंबर बढ़ता है। एटॉमिक नंबर बढ़ता है इसका मतलब उनके जो सेल्स है, के एल एम एन, जो भी सेल्स है, नंबर ऑफ सेल्स वो उतने ही रहते हैं, लेकिन लार्ज सेल्स में इलेक्ट्रॉन की फिगर है या इलेक्ट्रॉन की संख्या है वो बढ़ते जाती है। ये किस में होता है? पीरियड्स में। जब हम पीरियड्स में लेफ्ट टू राइट जाते हैं तब क्या होता है? तो एटॉमिक नंबर इंक्रीज होते जाता है बाय 1, और देयरफॉर द वैलेंस इलेक्ट्रॉन आल्सो इंक्रीज्ड बाय 1, बट द नंबर ऑफ सेल्स रिमेन सेम इन अ पीरियड. And what happen in group? In group, when we are going top to bottom in a group, the valence electrons in last cells is same. Understand? So we can say that the elements with the same number of cells occupied by electrons belongs to the same period. The elements in second period, namely lithium, barium, boron, carbon, nitrogen, oxygen, and at last up to neon, have electrons in 2 cells, K and L. The elements in the third period, that is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon, have electrons in the 3 cells, that is K, L, M. If you see this carefully, it means that in a period, first, second, third, the number of cells are increasing. Okay. So the electronic configuration of elements and confirm in the modern periodic table, the electrons are filled in the same cells while going along a period from left to right. जैसे हम लेफ्ट टू राइट जाएंगे पीरियड में तो उनके इलेक्ट्रॉन फिल होते जाएंगे एक 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 एक, लेकिन उनके नंबर ऑफ सेल्स कैसे होंगे, सेम होंगे. This is the characteristics of periods. The number of electron in first three periods determined by the electronic configuration of cells and the law of electrons octet. So how many elements in first period? 2 elements are there. In second, 8 elements are there. Okay, so all these are the follow electron octet law. Electron's octet law means when 8 electron in outermost orbit or outermost cell, then we will say that that atom of that element is stable. So this law is followed. What about third period? 8 elements in third period if we study there, and these periods are filled by one digit. Okay, so whatever chemical properties, okay, whatever chemical reactions are there, these reactions are possible because of these valence electrons in their outermost cells. So this implies or this indicates the reactivity of that elements. Student, I hope all of you understand this point, whatever we studied regarding with modern periodic table. हमने जो जो आज मॉडर्न पीरियडिक टेबल में देखा, मॉडर्न पीरियडिक टेबल का स्ट्रक्चर क्या है, पीरियड्स किसके बोलते हैं, ग्रुप्स किसको बोलते हैं, what happen, what is the characteristics of group, what is the characteristics of periods, what is how they are arranged in different blocks. I hope all of you understand this. You will read 2 or 3 times, it will be easy. If any difficulties, you can ask me. Okay, so take today's homework. You have to write the or you have to explain the modern periodic table. Okay, all of you write down this question, explain the modern periodic table. Whatever remaining portion, that we will see in our next lecture. Thank you, take care.